In this example, we're given f of x equals 1 minus x to the fourth power, and we're asked to find symmetry. So there's two questions, one on the left side, one on the right side. Let's work on the left one. To find out whether there's any symmetry in this function, we evaluate f of negative x. That's what we're doing right over here. F of negative x. Now use parentheses when you replace x in the given function with a negative x. So it's 1 minus parenthesis negative x, close parenthesis to the fourth. But negative x raised to the fourth is the same as x raised to the fourth. So this is 1 minus x to the fourth. So the double negatives are not crossing out. We're simplifying the exponent first, and since we know a negative base raised to an even power gives me a positive, we change the negative x to the fourth to x to the fourth. So we've got 1 minus x to the fourth. But guess what? That's exactly what f of x is, 1 minus x to the fourth. So we have demonstrated here that f of negative x is equal to f of x. That means we have an even function. Go back and look it up in the notes and in your textbook. An even function, as far as symmetry is concerned, tells you that there is symmetry in your graph about the y-axis. Next equation, given h of x equals x to the fifth plus x, find any symmetry. Well, the way we check again is we evaluate h, not f, but h of negative x. Careful, use parentheses, plug it into this equation, parenthesis negative x to the fifth plus negative x. But a negative base raised to an odd power gives you a negative result. So this is the same as negative without the parenthesis x to the fifth. Plus a negative is the same as minus x. Well, both of these terms have negatives, but they don't quite look like the h of x. But what if we factored the negative sign out of both of the terms? It would leave negative x to the fifth plus x, and the stuff in the bracket is h of x. So this simplifies to negative h of x. So we just proved that h of negative x is equal to negative h of x. That's different than the last one. The last one was f of negative x equals f of x. This is h of negative x equals negative h of x. What does that indicate? According to our notes, that gives us an odd function, and the symmetry related to odd functions is symmetric with respect to the origin. In other words, this function is invariant under 180-degree rotation, as we discussed in class.